Hey guys, welcome to the next unit. We're going to talk about vectors in this unit. It kind of fits nicely because we just did trigonometry, and I know you think trigonometry is done, but I'm sorry guys, vectors has trigonometry in it, but it's not too bad. So stay with me. If you've seen vectors before, great. If you've never seen vectors before, this might, for some of you, be the first time we've ever seen it. I want to first start with what actually is a vector. So before we begin, we're going to look at what it actually is. So there's two different terms I want you guys to know for this lesson. The first one is a scalar, and this is kind of what we're used to using most of the time. A scalar is a measurement with magnitude. And in most of our cases for this and our real life examples, it's going to be something like length or distance. So example, distance. A vector is a measurement with magnitude and direction. So that's the difference. So in this, for example, we could say distance north or south or east or west. It has to have a direction with it. So if you want to know the definition of a vector, it is measurement with both magnitude and direction. And if you want to do something a little bit fun, go watch Despicable Me 1 because the villain is called Vector because he has both magnitude and direction. It's my favorite line. What exactly is a vector? So in mathematically, what they're going to do is make it look like this. It's kind of like a line with an arrow on it. But there's a couple terms that I kind of want you guys to be familiar with when we're looking at vectors. So all vectors have a starting point, which is called the tail or the end. And then it goes in the direction in which it's going. And it has the head at the top. So they put a little arrow on it, but it's also called the arrow. Or the tip, anything like that. Tail end is the starting point, and the head or the arrow head is the end of it. And that's usually which direction it's going. A couple things about how they write a vector. So if I said that I had a vector U, it's going to be written like this. It's a like scripted U with a line with half an arrow on it. So it kind of has that little hook on the top of it. You'll notice in lots of my typing, I don't actually have that symbol, but that's what it is. Another thing that some of the textbooks kind of do with vectors is they will label it like this. They'll give a letter to the end point or the tail, and they'll give a letter to the head of it. And what you can do is write it A, B with a vector. So you can write it either way. So it could be like this, vector U, or it could be like this, A, B, where the first one is the tail and this is the head of it. So you write it in the direction in which it's going. That's going to come in handy when we do some of our examples later on and when we get into adding and subtracting vectors. So that's why I wanted to point that out. The other thing, anytime you're given a vector, you're going to be given magnitude, which in most cases is length. In some physics stuff, it might be the amount of force that's on it, especially for physics types problems. And you're going to be given a direction. Now, the direction can be in different ways. It could be up and down, left or right. It could be given in like compass directions, north, south, east, or west. It could be given as degrees, which we're going to get into. I'm going to go over how they actually give direction. So just be aware that you're going to be given those things when you're given a vector. A couple things to keep in mind. Equivalent vectors are vectors that have the same magnitude and direction. So, and they could be parallel. So an example of an equivalent vector would be one that goes like this and another that goes like this. Notice how they're both going in the same direction and they're about the same magnitude. If I could, I'd put them exactly the same magnitude, but for the purpose of our notes, they are the same magnitude. So notice that. Opposite vectors are parallel, so they have the same magnitude. And they are parallel, but they go in opposite directions. So if I was to do this one would go this way, and my opposite would go that way. So still parallel, they have the same magnitude, they're just pointing in opposite directions. Let's move on to the other page, and I'll go over some examples and we'll talk about how do they actually give the direction. Okay, so direction is really important, and please pay attention to the questions because they ask it two different ways, and the different ways ask you for different things. And so I don't want you to get confused on which actual bearing that you have to do. So direction can be expressed as a true bearing, or they'll just use the word bearing. So if it's just bearing all by itself, it is the true bearing. Or as a quadrant bearing, and I'll talk about how that works. True bearing is, and most of it is, we have our compass, north, east, south, west. So it's going to be a little bit different in terms of what quadrant it's in. So it works differently than what we just did. All they've done is it starts from north, so north is 0 degrees, and it's expressed as a 3-digit number measured clockwise from north. So we're going to go in this direction all the way around. So here's 90, this is 180, 270, all the way around is 360. So when they give the bearing, they're just going to give you a 3-digit number. So for example, this one is approximately, let's say it's 150. So they would do a true bearing of 150 degrees because it is 150 degrees starting at 0, going around to 150. So that's the true bearing. Quadrant bearing is an angle that's between 0 and 90. So they always stay between 0 and 90, but it's measured east or west from the north-south line. So always start on the north and south. Because this one is down in this quadrant, it's south. So you would start at south, and then you would go this distance, which is 30 degrees. 30 degrees to the east. So be careful about what bearing it's actually asking you for, because these two mean the same thing. So I could give you the true bearing of 150 degrees, or I could tell you it's south 30 degrees east. They're exactly the same thing. They're just written differently. So it means different. It doesn't mean anything different. It's just written differently. For those of you who are in like aviation type stuff are going to need to know this kind of quadrant stuff. This is kind of good to know. And the questions will ask it different ways. So careful with that. Let's do an example. We're going to describe each vector in words. So all I want you to do is tell me what is happening. Now, I didn't put it on here, but it's always, north is always the up. North, east, south, west. So when you do it on the page, you're always going to do it this way. This doesn't change. So the first one, if we want to talk about how this one is measured, we could do it in two different ways. We could do the true bearing, or we could do the quadrant bearing. I'm going to start with the quadrant bearing because I like that one. But this one, the vector, is 8.7 knots. That's a force on it. And then it is south, because we're going to start north or south. It's in the south, 25 degrees to the west. If we wanted to do this as our true bearing, I would go around here to 180 and then add the 25. So 180 plus 25 is 205. So my true bearing would be 8.7 knots, 205 degrees. Same thing, written two different ways. Last example, so I kind of go over it one last time before I let you guys go. Same thing. I'm going to start with the quadrant bearing. This one is 32 meters. So it might be that I walked 32 meters. Where did you walk? I walked. And this is, again, it's south. Now, it's 180, but minus the 110, because I want to know exactly what this angle is. So it is south 180 minus 110, which is 70. So south 70 degrees east. And then our true bearing, which they've given us, is 110, 32 meters, 110 degrees. Both ways are acceptable. Just be careful about what is actually listed in your example. That is it for me for your intro to vectors. There's a bunch of practice stuff about which is a scalar, which is a vector. Scalar, remember, it only has measurement. Vector has measurement and or magnitude and direction. So if it's something that has a direction, then it's a vector. Good luck with the practice question, guys, and I'll be back with more things to do with vectors. Bye, guys.